So this is example 2 for our calculus video 15, where we are differentiating composite functions using the chain rule. So in this example, we want to use the chain rule to differentiate this function here, y equals 5 over x squared plus 4. So the easiest thing to do here is to perhaps rewrite this a little bit. So let's just rewrite it as y equals 5 times x squared plus 4 to the power of minus 1. Let's recall the chain rule. And that is dy over dx is equal to dy over du times du over dx. So let's assign u as x squared plus 4. So that means we can substitute in u for x squared plus 4, and we can rewrite our function y. We can rewrite our function y as equal to 5 times u to the minus 1. And so now we have y in terms of u, and of course u is in terms of x. And so now we can apply our chain rule. Let's first find dy over du. So that's going to be this part here of our formula. So dy over du, we differentiate that using our knowledge on differentiating powers of x, but now we have u. And so what we do here is we bring down the power, multiply it by the coefficient, and then we take away 1 from the index. So that's going to be equal to minus 1 times 5 is minus 5 times u to the power of minus 2, because we took away 1. Okay, so dy over du is equal to minus 5 times u to the minus 2. And then we want to find du over dx. So du over dx, we want to differentiate the function u with respect to x. And so we can do that because we know u equals x squared plus 4. So then let's differentiate x squared plus 4 with respect to x. And the same thing that we did before, x squared differentiated becomes 2x. And then plus 4, when you differentiate a constant, you get nothing. So du over dx is just 2x. And so we can substitute these back in to our formula for the chain rule to get dy over dx equals dy over du, which is minus u to the power of minus 2, times d over dx, which is just 2x. But of course, we want dy over dx all in terms of x, but we have x here, and then we have it in terms of u here. So what we need to do is we need to substitute in u equals x squared plus 4. So we can get this all just in terms of x. So in fact, dy over dx is equal to minus 5 u to the minus 2. That's x squared plus 4 to the power of minus 2 times 2x. And if you want, you can always rewrite that. Maybe simplify this part here. So we're doing minus 5 times minus 2. That's minus 10 x there. And then we can write that as over x squared plus 4 to the power of 2. And we have differentiated our function y with respect to x using the chain rule.